Hello everyone and welcome to a lesson of physics. So today we are starting off with the past paper practice of the topic polarization. And some of the questions, for example, the first one, you won't find it on the workbook of waves, part 1. You won't find those questions over there, but some of the questions are there already on the workbook. So I've sent the worksheet anyway. If you see some of the questions are not there, you can get those printed, or if you want to print all of it, you can, totally your choice. But let us start off with the first one. And before I start off with the questions, let me write down the formula, the important one that would be used in the topic of polarization. One of them is I equals to I naught cos square theta. We studied this as a law. Now, what is I? It is the intensity after the analyzer. What is I naught? It is the intensity of the light beam before the analyzer. What is angle theta? It is the angle between the light and the axis of the slit. If the light is vertical, the axis of the slit is also vertical, the angle would be 0. And there would be no change in intensity as it passes through the analyzer. But this formula does not work for the light which is to be polarized. It works only for the already polarized light. So in most parts, like for the most part, you'll be given with the questions in which they give you the light which is already polarized, which means it was passed through the first filter, and after passing through the first filter, the light was polarized. Like 99% of the times, they'll vertically polarize the light. So let us start off with the questions. A beam of vertically polarized light of intensity I naught. So you see, where does the question starts from? A beam of vertically polarized light. What does that mean? It means the light beam is polarized already. They might have used a filter paper and they would have polarized the light. So a light beam and unpolarized light would have been passing through the filter, which would have been placed vertically, and hence we have a light which is vertically polarized, and the intensity of the light is I naught. So after getting polarized, the intensity of the light is I naught. And we can also say before the light getting polarized, the intensity would have been 2 times I naught, because once the light is polarized, its intensity is reduced to half after it passes through the very first filter which polarizes the light. So from unpolarized to polarized light, the intensity is reduced to half. So it means initial intensity would have been 2 times of I naught. Okay, so this light is incident normally on a polarizing filter that has a transmission axis at an angle 30 degree to the vertical. So this polarizer that they have shown over here, now technically this is the first analyzer. So this is your first analyzer, and it is placed at an angle of 30 degree with respect to the vertical light. So intensity before the analyzer is I naught, intensity after the first analyzer is I1. And then we place another analyzer. So this is technically your second analyzer, and intensity after the light passes through the second analyzer is I2. So they have used 3 filters. The first filter would have been over here, something like this. So behind it, the light would have been unpolarized. Means the oscillations would have been pretty much in all directions, something like this. And this is what we would have called the polarizer. So after the light passes through the first one, it becomes polarized, and then it passes through the first analyzer, which is placed at an angle of 30, and the second analyzer is placed at an angle of 90. But let me tell you one thing, keep it in your mind, that's a rule of thumb. Whenever you state the angle of the second analyzer, you have to mention the angle of the analyzer with respect to the previous analyzer. The previous analyzer was at 30. It was already at 30. So you mention the angle with respect to the previous analyzer. So in this case, the angle of the second analyzer would be 90 minus 30. So theta in this case would be used as 60. And for this one, theta would be used as 30 degrees. Because the previous polarizer was already vertical, so we have the same angle from there. And let me get rid of the extra stuff. For example, this one. So let's see what have they asked in the first part. They asked us to find the ratio of I1 over I naught, the ratio of this intensity to this intensity. Now we have the analyzer in between them, so we can safely use the law, and the law reads nu intensity or intensity after the analyzer equals to intensity before the analyzer times cos square theta. Intensity after the analyzer is I1, before the analyzer is I0, and the angle is 30, so cos 30 and then square of the whole function, not square of 30. We have to be very careful with it. And since we need to find the ratio, I can shift I0 on the other side. It will look something like this, and we have cos 30 and square of it. And you open up the calculator, cos 30, and then take square of it. We get 0.75. So 0.75. So let's take a look at the next part, which is slightly tricky. Now we need to find the ratio of I2 to I0. I2 over I0, that needs to be found out. So let's see what I2 and I0 is. So you see, I0 is the intensity of the polarized light before the first analyzer, but I2 is the intensity after the second analyzer. Now once again, keep it in your mind, a very important pointer: you can never use the formula by skipping two filters at the same time. So that formula is directly, you can apply that formula directly for intensity before and after the analyzer. But in this case, we have two analyzers in the middle, so we cannot directly write down the formula. So like what I'm saying is, if you use the formula I2 new intensity equals to old intensity times cos square theta, and use the angle of the second analyzer as 60, I2 divided by I0 cos 60, and then square of it, we are not going to do that, because after the first analyzer there was a change in the intensity, and after the second analyzer there was another change in the intensity. So we have to compensate for the two changes. So what we want is, we want to go through both the analyzers one by one. So let me do a mathematical trick here. So what I'm going to write, I2 over I0. Now this thing can also be written as I2 divided by I1 times I1 divided by I0. Now first of all, mathematically, the left hand side and right hand side are consistent. There is no violation of the mathematics. And the advantage is, in this way, we don't have to bypass the two filters at the same time. We can find the intensity ratios of each filter, each analyzer separately. Because if you simplify this thing, mathematically, I1 and I1 would be cancelled out and you'll be left with the same thing. So what we have is, the thing is, we already have the ratio of this thing. We already have the ratio of it. How much is that? It is 0.75. We just calculated in the first part. It is 0.75. So we write 0.75 over there. All we need to find is I2 over I1. So let's go back to the diagram. Here we have over here. So this is the I2, this is the I1. In order to relate I2 and I1, we don't have to skip two filters at the same time. You see, we have only one analyzer in between. So I2, the new intensity, equals the old intensity times cos square theta, which in this case is 60. And like I told you, you have to use the angle with respect to the previous analyzer. Don't take the angle as 90 degrees. So let us find the ratio. This one would be I2 over I1 would be cos square of 60. And we can simply hit it on the calculator. It would be 0.25 because cos 60 is 0.5, and then square of it would be 0.25. Now we do have the value of I2 over I1, and we also have the value of I1 over I0. So we multiply these two, this thing times 0.75. What do we get? We get 0.187, which we can write as 0.19. So 0.19 is the answer for this one. So let's move on to the next one. The next question that we have over here. Let me scroll down. Okay, we have it over here. All right, so for the next question, for the first part, we have to, the question reads, polarization is a phenomena associated with light waves but not with the sound waves. In the first one, you have to state what is the meaning of polarization itself. So restricting the oscillations of a wave, of a transverse wave in one direction only, is called as polarization. Then we have for the next one, statewide light waves can be plane polarized, but sound waves cannot. So we do the polarization can be done for the transverse wave. Light waves are transverse waves, they can be polarized, but sound waves are longitudinal waves. So let's take a look at the next one. Two polarizing filters A and B are positioned so that their planes are parallel to each other and perpendicular to the central axis xy as shown in figure 4.1. Okay, we have the unpolarized light. We use the first filter. The light is polarized and the intensity of the polarized light is I naught, which means the intensity of the unpolarized light would have been 2 times I naught. It's not mentioned, but we know it anyway. And then we have the second filter, which in this case is the analyzer. And the first filter is polarizer. And let's say the intensity of the light after passing through the analyzer is I. And let's see what do we need to find. Okay, after rotation, the intensity of the light emerging from the filter B is I naught over 4. Okay, so I gotta change it. The intensity is I, which equals I naught over 4. Or you can also write it as 0.25 I naught. Okay, just to make it easy for you, 0.25 I naught. This is the intensity of the light after it passes through the analyzer. And the filter B is serving as the analyzer. What is the filter A? It is a polarizer. And we cannot use the formula. We cannot use the law for this one because this is a polarizer. And the law, the Morse law, that works only for the light that is already polarized. So the light gets polarized only at this stage. So we can use the formula from here on. So what do we need to find anyway? We need to find the angle. Okay, so it's simple as that. New intensity equals to the old intensity times cos square theta. What is the new intensity? 0.25 I naught. What is the old intensity? I naught cos square theta as it is. I naught cancelled out. So 0.25 equals cos square theta. Then you take square root on both sides. Cos theta equals to square root of 0.25 and theta equals to cos inverse of 0.25. Then we open up the calculator. We press the shift button and then cos. Then we place square root 0.25. We get 60 degrees. All right, so for this one, we get 60 degrees. Theta equals to 60 degrees. Now, what is this angle theta? Now, first of all, we need to find the angle of rotation, but what we have is the angle theta. What is the angle theta? Theta is the angle between the axis of the slit and the incident light. Okay, this is the angle theta. The angle between the axis and the axis of the slit and the light. This is the angle theta. So what we do from now is we have to find the angle for the direction of rotation. So if I show you the diagram over here, so for this one, you see this angle, if that's the vertical slit, if I redraw the vertical slit, this is the direction of light. As it enters the first analyzer, this is the direction of light. And the angle that we have is 60 degrees. The angle that we have is 60 degrees. So that is the angle between the axis of the slit and the light. The angle between the axis of the slit and the light. So what we do is we see the total angle would have been 90. This angle would have been 90 from here to here. This angle is 90. And the final angle on that angle of 90, the final angle that we have is 60. So by how much angle do we rotate the filter so we get the final angle as 60? So the answer would be 90 minus 60, and thereby we get 30 degrees as the angle of rotation. So if the question were what is the angle between the light and the axis of slit, the answer would have been 60 degrees. But the angle for direction of rotation, you have to subtract from 90 in this case. So let's take a look at the next one. So this one is about the stationary waves, and we won't be able to solve this one. And the next one also, in which we have to find the maximum amplitude. We'll solve these the part C once we are done with the topic of stationary waves and superposition of waves. So let's move on to the next question that we have, question number 3. So let me take a look at this one. I'm not going to read the question now. We need to find amplitude of the transmitted light IT divided by I naught. That needs to be found out, and let's see if we can use the formula straight away. And the answer to that is yes, we can, because the light is already polarized. A beam of vertically polarized monochromatic light. So it means the light was already polarized. So you see, this is the already polarized light. So the filter that we have here is not the polarizer, so technically is the analyzer. So new intensity equals to I naught times cos square of the angle. So what is the new intensity? It is IT. What is the old intensity? It is I naught as it is. What is the angle? Well, the angle is given in this case very easily. We can write cos square theta, and theta is 20. So IT divided by I naught equals cos square of 20, and we get 0.88. So we get 0.88 for this one. Okay, sorry. This is the ratio of IT over I naught. Okay, this is the ratio of, but we need to find the amplitude of transmit. We need to find the ratio of the amplitudes. All right, we can easily find the ratio of the amplitudes once we have the ratio of the intensities. So let me write down the formula that relates the intensities with the amplitudes. That is I1 over A1 square equals to I2 over A2 square. We studied this formula in the topic of intensity of the wave. And what do we need to find? We need to find intensity. Let's call this one I2. Let's call this one the first one. Sorry. The second one, transmitted light, is I2, and the previous one is I1. Okay, over here, or if you want to use the same subscripts, you can use the same subscripts also. IT over incident would be called as I naught, and here we can write the formula in terms of these subscripts. And the amplitude at the incident, let's call it I naught, and amplitude over here, let's call AT. We can use the same formula, but for these subscripts, it would be IT divided by AT square equals to I naught divided by A naught square equals to, if there were any other intensity, it would have been divided by amplitude at that intensity, square of the amplitude. So if you write IT over here, you have to write square of AT down below. So likewise, IT divided by I naught, then I'm going to change the position of these two things, equals to AT square divided by A naught square. What's the value of this thing? Well, the value of this thing is 0.88. So I'm going to write this thing equals to 0.88. So what's 0.88? That's the ratio of squares of the transmitted to incident amplitude. That's the ratio of squares of the amplitude. But we don't have to find the ratio of squares of the amplitude. We have to find the simple ratio. So hence I'm going to take square root on both sides. So if you take square root on the left side, you'll be left with this, and the square root of 0.88, square root of answer, that equals to 0.9396. So it would be 0.94. 2SF can be written as 0.94. And the polarizing filter is placed at 20 degrees. Now for the next part, the filter is now rotated from its starting position so that the angle increases. Okay, calculate the minimum angle to which the filter must be rotated so the intensity of the transmitted light returns to the value that it had when the filter was at its starting position. Now they ask you to find the minimum angle. The easiest way to do that is you can draw the plane. We can draw the plane first, XY plane, like this. And the previous angle was given as 20 degrees. So angle here was 20 degrees. So what does that mean? It means the filter is placed at an angle of 20 degrees. So this angle, 20 degrees. And if I draw it on the other side, and this is a shortcut, by the way, what you can do is in any question like that, you can draw an angle 20, whatever the given angle is, draw the same one on the left side also. Okay, this is what you have to do. Whatever the given angle is, just check it from the diagram and draw the same angle On the other side of the axis, on the other side of the y-axis, draw the same angle. Now we need to find the minimum angle to which the filter must be rotated. So in order to get the shortest angle, in order to get to the same position, I'll be getting the same intensity if I reach the other side. Now I have two options to reach to the other side. I can reach the other side in two different ways. One of them is if I follow this path from here to here, and the other option is if I go from here to the other side. So we have two options. But since we need to find the minimum angle, so I'll follow the first option, because you can see mathematically if I choose a lower path, let's call it the path 2, then the angle would be greater compared to the first one. In order to find the minimum angle, choose the shorter path. Now what is this angle? It's no longer a question of physics, it's a question of mathematics. If you need to find this angle, you see the total angle on a straight line would be 180. So you say 180 minus 20 and then minus 20 once again. You subtract these two angles and what we get is 104, yeah, 140 degrees. And I think that question was for 1 mark. So that's once again a very easy takeaway. Whenever you have to find the minimum angle, draw one angle, the given angle on this side. For example, I just copy paste it from the diagram, but draw the same angle on the other side and choose the shorter path. Whatever the shorter path is, that would be the minimum angle. So that's it for today. See you in the next lesson. Take good care.